Hello everyone, today I'm going to discuss about keys. So we have formulas regarding keys. So we have shearing stress. Shearing stress is just force over area. So we have 2T width times length times the diameter of the shaft itself. Okay. So what we have here is the 2T over D is just force because we know that um torque is just force times radius. And we know that radius is just diameter divided by 2. Okay? So by doing that, we have F diameter over 2. And then we, let's say, multiply 2 on both sides. Now we have 2T is equals to FD. And divide D on both sides. Then we have force is equals to 2T over D. That's why we have 2T over D. And we know that since it is a shearing stress, the area is parallel to the force. So we have the area of width and length of the key itself. So we move on to the compressive stress. So this should be C. And we have force over area for T over D. Why does it have for T? Since we consider height as divided by 2, so let's say we have 2T with height divided by 2 and the diameter, we just multiply 2. I mean, we just bring 2 in the numerator. So we have 2 times 2 torque with height, then diameter of shaft. Then we would have 4T over width, height, and diameter of shaft. So you might be wondering, what is this shaft? So in key, we have a shaft, okay? And we have the keyway. This is where you'd put the key itself, okay? This is the keyway. And we would have a, let's say, hub, okay? So this is where we put the shaft, okay? So I might suggest that you look up what keyway, let's say, do. So we have a shaft here and a key and a hub. So the main idea of a key is to prevent slipping from different uh, joined, let's say, shafts. Okay. So the diameter that we talk about is the diameter of the shaft itself, where the key takes or rests. Okay. So here we have let's say number 3 formula. We have power. So power is just the power provided or experienced by the key itself. We have power of watts and T of torque of Newton meter, and then a RPM, uh, RPM, so revolutions per minute. Since, I mean, this is not revolutions per minute, but revolutions per second. But since most of the givens are in revolutions per minute, most, let's say, power equations comes with the conversion. So power 2 pi Tn over 60. What is this 60? So we know that revolutions per minute, okay? So we know that 1 minute is 60 seconds. So here we have n here and cancel, cancel. Now we have revolutions per 60 seconds. So that's why we have 60 here, okay? So onwards to So onwards to our first, let's say, problem. We have determined the key length of square key for gear-driven shaft to withstand a torque of 2,891.4 Newton meter. The shaft diameter is 65 mm with a design stress of 72.6 megapascal in shear. The thickness and width of the key is 5/8. So we have a given. So given for torque is 2,891.4 Newton meter. And the design stress in shear of shearing stress of 72.6 megapascals. Okay. And the thickness and width. So the height and width of the key is 5/8 inches. So we need to find its length. So solution, solving. Let's first say uh, write the formula. We have 2t over shearing stress is equals to 2t over width times length times the diameter of shaft. Okay, so here we have the torque of 2,891.4. So we have 2 times 2,891.4 Newton meter all over width. So what is the width? Width is 5/8 inches. So we have, so what is width? So we have width of 5/8 inches, and we have a length of here. And we have the diameter of shaft, which is 65 mm. So as you have observed, we have different, let's say, units. So we have to convert them. Now we have 2,891.4. We just multiply it by 10 raised to 3 in order for the Newton meter to become Newton millimeter. Okay? Times 10 raised to 3 Newton millimeter. And then the 5/8, we know that 1 inch is equals to 25.4 millimeter. Therefore, 5/8 inches, 1 inch equals to 25.4 mm. Okay? I mean, that's 1 inch and 25.4 mm. Okay? And now, 5/8 multiplied by 25.4. Then we have 15.875 mm. Okay? So let's erase this. We'll have 15.875 mm. Okay? And now we have a shear stress of 72.6 megapascals. So what is the unit of megapascals? So megapascals is just Newton per mm squared. So yeah, that is, now we have the length of, so 2 times 2,891.4 times 10 raised to 3, then 15.875 and 72.665. We would have 77.19 millimeters. So how do we know it's millimeters? So cancel the unit out. We have mm, and cancel, cancel, cancel. and Newton, Newton, and we would have millimeter left. So problem solved. Okay.